very small basic things. These are the lines of force for unlike charges. Equal unlike charges is what I have plotted here. Now, what is the question? A test charge released in electric field of two unlike point charges. Will it move along the lines of force? Is asking. Okay, now let me do one thing. I will release the charge particle here. Test charge, no, Q naught. So here in what action the force will be? F1. By the time it reaches here, test charge, the field here will be E2 like this. So therefore the force, it will be experienced like this, but it will have velocity directed in this direction. See, like if you release a test charge at 1, okay, let's assume that this point 2 is very close to it. By the time test charge reaches here, let it the electric field. So how to get the electric field? If you draw a tangent, if you want electric field here, so what you should do? Draw a tangent. Similarly, you want electric field here. Draw a tangent. You want electric field here. Draw a tangent. So at what point you want electric field? There you draw a tangent. And that will give the direction of E bar at the point. So therefore, what will be the E bar at this particular point? The lines of force. I'll draw a tangent. And the electric field strength into the charge will be the force. Because of force, it will accelerate. By the time it reaches point 2, this 2 is very close to 1. It will experience a electrostatic force along the lines of force only. But since the force F1 was acting horizontally somewhere at this point, so therefore it must have velocity V like this. Now, because of velocity and force, how the particle will move? The particle is going to trace out a path like this. So it's a rough idea. So what is this path? This is the green color one is path of a charge particle. So therefore, if you release a test charge in a field, will it move along lines of force? No. The answer is no. I'll write it here. So, so is it lines of force are the path traced by the unit test charge? The answer is no. Maybe for isolated point charge, okay, but for like this lines of forces, so when there are two charges are interacting, the test charge will not move along the lines of force. The pink color one is the path of charge particle. I'll try to indicate something. Path of test charge. Path of test charge. The test charge will move like this, will not move along the velocity or along the force, the resultant path. Okay, we'll move on to the next. No. I'll keep a point charge Q. I'll ask you to plot the resultant field, the electric field strength. We know what is the formula for electric field strength. E equal to KQ by X square. What is X? This point is what? X equal to 0. This will be X positive. What about this? X will be negative. And E will be positive here. And if E is negative, it should be like this. If E bar directed towards right, it should be positive. If E bar negative, it should be directed towards left here. So we know what is the electric field strength here. It should be towards left. So therefore it will be negative. E bar here will be towards right. On the right hand side of point charge, the E bar will be towards right. So therefore it will be positive. And put X equal to 0. It will be infinity, no? So we do show like this. somewhere at infinity, and put x equal to infinity should be 0. So therefore the curve, not rectangular hyperbola, x square is there, no, the curve will be of this form. Similarly, same thing here. If the negative point charge is there, E will be towards left on the right side, no, for x greater than 0, E will be towards left. For x less than 0, towards right. So